All right, I wanted to do a little bit of a how-to on the Cepheid Variables Lab. So we have these equations, the distance equation based on the uh, apparent magnitude little m, the absolute magnitude big M, and that distance modulus is used to calculate our distance in parsecs. So this was the task of this lab, was to use the graphs of some Cepheid variable stars to find their apparent magnitude, their absolute magnitude, and then use that to calculate the distance to those stars. So this is the basic graph. And when we look at this graph, the period of this star is measured by the distance between peaks. So for example, that could be the distance in time between this peak and this one. And so for this star in particular, it looks like the period is around 1, 2, almost 3 days. So about 3-day period for this particular light curve. And so this period is one important piece of this light curve. The other piece is the average apparent magnitude. So if we take the maximum apparent magnitude and the minimum apparent magnitude and take the average of those two numbers, then we will get the average apparent magnitude. Let's see, this one is something like maybe 3.5. This one looks like it's something like maybe 12.5. So the average of 3.5 and 12.5 I can get by adding them together and dividing by 2. And that gives me something like 8. So if I'm right, then I should be able to say that the average apparent magnitude here is about 8. And I got it. All right, so that's how I find the quantities that I'll need in order to do this lab. So let me go to these particular stars. As an example, if I wanted to find the period of this second star on my list, then I would be measuring the distance in days between its peaks. And in order to find its average apparent magnitude, then I would be finding the maximum and the minimum points and then adding them together and dividing by 2. So that's how I find the average apparent magnitude M, whereas this pink curve I drew is how to measure the period. P. All right, so those are the two quantities I'm going to need, but the period is important only because it gives us the absolute magnitude big M. And the way that I get that absolute magnitude based on my period is using this period luminosity relationship graph that was conceived by Henrietta Leavitt. So this was her big discovery in, I think, what, 1912. And the way that we use the period to get the absolute magnitude is like this. If I have a star that has, for example, a period of 20 days, then all I do is I draw a line straight up from my period number to that period luminosity relationship line. And then I follow that back, over on my y-axis, and the absolute magnitude, big M, is found over here. So a star with a period of 20 days would have an absolute magnitude of -5. And so your task in this lab is to use the graphs of these 4 stars, find their periods, use the period to find the absolute magnitude big M using that period luminosity relationship. Then separately, you'll use the maximum and minimum apparent magnitudes to find the average apparent magnitude little m. And then at last, you can calculate the distance to your star using the equation at the top of the page. All right, so that is the overall process of this lab. Again, feel free to email me with any questions or come to a help session if you would like some assistance, especially using the spreadsheet to keep track of and calculate data. I hope this helps.